Okay, looks like I'm live. Let's check my mic. Okay, mic is working. Bot is live. Righty. So I'm stuck on day 7. I actually borrowed the idea of somebody else, which is kind of a cool idea. Which would be to generate every single operation with binary, which has been working great. Now I only need to be able to make the operations in and of itself. So I'm getting the operation vector, which would have every vector of every possible operation. Then I'm going to iterate based on every operation, or rather every vector of operations. Now I need to iterate over my actual list. D.sequences. Was it sequence? Type data for L in D dot. Actually, it's going to be IL in D dot sequence. Obviously, we're gonna go that iter dot enumerate. And following this, we can then, I want to jump if it's 1. So if I is 0, my let accumulator, so h equals 0. Naturally, this would be a mutable accumulator, which is 0. Now, if I'm at operation 1, I don't need to do anything. I'd rather just make my accumulator look like him. So accumulator will be equal to L. Found the integer. Okay, derived. Very well. Otherwise, I need to match. So I'm gonna get out the operation. So let op equals ops.get I minus 1, because we're gonna be slanted by somebody else. Else continue. Rather break, because we're not gonna go ahead if we don't have a valid operation over here. So that's gone. And finally, we're gonna op.match. Why is this an option? This, all right. Let's just say some op, right? I'm gonna fill the match, so it'll be ac plus equal L, or ac times equal L. Also derived. Great. Now, once this is all over, we can check that my boy should be, was like summit. So let mut sum equals 0. And afterwards, if we find one possible operation, if sum is equal to accumulator, then we can simply say that's not sum, rather d dot is equal to accumulator sum plus equal plus equal to accumulator. I can get rid of the pretty print, we can print the sum, and we run it. Takes a bit of time. Attempts to stack with overflow. How the fuck? 69G. Oh, my bad. There should be a continue. First one shouldn't not run. 3, 2, 6, 7. This is the only one that works. Well, good news is that that is a correct one. If I remember, yeah, this is the correct one. But 10, 19 should also work. Maybe I need to get out the lane. I want to print out what we have here. So I want to print out my operation and my ACK. Print num, which is sum, is equal ACK. Num would be L, and op is op. So num is 40 what? Why am I jumping 190? So I'm straight up jumping 90. For row in TMP, for L in row, print L, print L on. It should be an operation, right? Okay. So is plus time, time. So this is not how the iteration are supposed to go, because you have to be either plus or either times. By the way, the two ones doesn't have like plus time plus. That's not good. Yeah, okay, so this here should be a len of 1. Maybe we can also print len. We can distinguish it. Data sequence dot len -1. And let's print another space at the end just so we can. It's a number, so should be formatted right. Okay, so len2, it's plus times times times. It isn't that. Does this mean I have to respect 2? Also, the fact is that I don't have times plus. I have plus plus, but I don't have times plus. Which is bizarre. There should be a time where there's plus plus because you can have 0, 1, 1. Oh, because I don't have the 1. Right. I don't do the padding. That's the problem. Without the left padding, there's going to be something missed out. Well, so how could we get the padding? Because there's going to be like 0, 0, 1, and so on, and so on. Meaning that in this case, where it should be like plus times and times times, this will be plus times 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 and times plus. Yeah, I still miss some cases. Or based on the padding. I should be based on the length, adding a padding before. Is there any function that does that for me? How to add the how to from int to binary string Rust. Okay, so we do have binary numbers in Rust. Well, this will make it easier. Okay. So this is better than my operation. Which will then mean that I'm going to simply go one by one and operate over it. So for I in 0 to length included, Rust from int to binary. So string to binary. But can this be like also, I don't know, 17? Yeah, right. So that would be let tmp that's equal length format okay, I.b. Right. This is a binary string. Now this binary string I can collect it as an array. Perhaps to like, let's say, oh well, for L in tmp, L.match one is malt. In any other case, let's push some that's interesting. Ciao ma, buon lavoro. So it's going to be plus times times plus times times plus what? Oh, I fucked up the function. Oops, 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 oops. My bad, my bad. This isn't how it's supposed to go. We're supposed to just take the number and or rather the string, so that would be num slice what str well new sides. Then we simply format. I'm gonna iterate over here. Don't remember where was it. It was here somewhere. So we can go from 2. But we have plus equal times times. Yeah, we'd also want a 1, right? So let's start from 0 or 1. Even 2, but we can start from 0. Honestly, all the same. Gonna be plus times, there you go, 3, 4, 5, 7. I think it was 3, 7, 4, 9. Yeah. So there's progress. So yeah, line length 1 plus times plus, but there's not plus time for some reason. And again, stuff doesn't go that far. Am I fucking up how the possible... the longest is 4 in this case, right? So 4 should be 2 times... 2 times of 4 would mean 16. But I'm getting only to... This is like 6. Okay, so 0 is plus and 1 is times. Then 0, 1, 1, 0, and we stop at 6. Why we stop at 6? Rust how to elevate. Rust pow. Because I'm doing an OR, we're not doing a pow. I think the pow is different. Pack times pow, motherfucker. Don't call it pow an ambiguous numeric type integer. Don't call pow an ambiguous integer. What the fuck does that mean? Rust. Oh, well, I mean like as you sides. U32. Special expected U side found U32. Okay. This will be a U side U32 equal to longest array. Okay, then these are foreign signs, which is more than the numbers I have. So I'm thinking about it would be, first off, it will be -1. And that should remove the extra case. Then it would also be longest array -1. All right, and now we have every possible case. By this point, my math should be mathing, but it isn't, because 3, 4, 6, 7. 3, 4, 6, 7, it isn't the one. So we should be taking a look at what precisely are we hitting. Good. If total, print hit arc. Wait. Yeah. So we hit 190, we hit 3267, but we don't hit 292. Okay. Interesting. And how will I print this out? Because at some point I'm going to have, so this is my ops and this is my mod operation. So I'm looping over the current data. I could say if d.dot equals equal to 92, print arc. All right. Well, it makes sense, doesn't it? Also, we would want to print the op. So print the accumulator, print the L, and well, we don't need to do that. Okay, this time I actually didn't fuck up. So op L. Okay, this looks nice. Right. Then we print a new line over here and see what the fuck is going on. So 11 times 66 plus 16, and 82 plus 20. That's one. Good. 11 times 6. Okay. We have every possible combination, which should work. The one that should be working is 11 plus 6, 6 times 16, and plus 20. That'll be plus time plus. So I don't have plus time plus. Bizarre. I don't have time plus dice. Motherfucker. Why? Brother. I don't have one combination. Am I generating it? That's the question now. So time plus plus. Time plus time. Time plus. And alright, because we don't have again the padding, so it's going to be 0, 0, 1. Yeah, the padding stuff. How could I forget? How do I pad this shit? Because I can print it out, but I also would want it to be like 0. There's also going to be like 0, 0 and stuff. Yeah, and also these pads would be used later on. But the other way in which we can make it behave differently, if I can always pad it, I could just use the first one of the types, you know? I could be, instead of having every possible combination, I can pick whatever it is. Yeah, but that's more complicated than that. Too bad, because this idea was nice, but I don't get the byte iteration here. Yeah, because it would be 0, 1, 1, 0, 1, 0. I missed the 0, 1. Yeah, but I can turn it back around. So every time that I need something, I should be taking the last bits that I need. So I should do this and reverse. That's a good idea. So, all right, this is how you do it. What is... Rust format with padding. Okay, so I can put the padding here, and the padding should always be like, wait, is this a static padding? No, it isn't. All right. So the padding here should be, can it be also a variable? Let a equals 5, and I can put a here. Well, I mean, if I say like 10, shouldn't that be enough? No matter where am I? I'm just going to reverse this list before pushing it. So op.rev. Set construct found unit. Didn't work, brother. Brother. Ah, wait. Now, rather than operating on how many ops we have, we're gonna iterate over we can iterate twice over my sequence. No, because that's not how it work. But at least we have the padding, right? Should probably pad it based on the num that I'm getting. Can do that. So this is my base case. Yeah. So this prints. So is this a string? Yes. Return string. Okay. Let's say that I know what I'm doing, and I should pad every time that I jump the power, right? So every time there's one power up, I should be jumping. Num times match. Okay, if it's 2 pow, can't pow it. God damn it. Let num use size equal to, rather let L so equal to size 2 dot pow. I can't pow because it has to be U32. Okay, dot pow. Method calls are not allowed. Well, accurate padding should return depending based on how further along it is. Yeah, should be saying like 2 to the power of, and my exponent should be, okay, so for loop and let exponent be 0. This is G32. 0. Base should be 132. And if num is wait, can I say something like, I don't know. Okay, I can string out the number and the number of bits, right? So I should be able to return like num to string plus x to string. Okay. All right then. If num is bigger than arc, we can return the num and the exponent. This way we can just use that over there. So let padding equals, what was B? B stands for binary, right? So wait, no, it's exponent plus B. Okay. And padding would be equal to accurate padding of num, and we put padding here. Can make custom padding. My God. So still back at square one. How do I pad this out? I can pad it in a crazy way. Again, I think that the play is, I'm just gonna pad it like an unbecoming, let's say 10. Then we have this situation. Now, rather than iterate over everything, I'm going to iterate over, this will change how I iterate. Rather than iterating every single time over every operation, which is not what's intended, I would iterate from numbers to -2. Means they have two, if I have two operator, I have two different cases, right? So then ops, it would be in 0 to d dot sequence dot len. And by the way, we return the reverse, which is good, right? This is how I uncapsed it, but that's fine. Because at this point I can just get Like this one is not needed anymore. I can just push it in an array and just pick it in order. So possible ops is going to be a back operation. This would be just simply a push TMP. Okay. And how do I get my op? I'm gonna say I and let ops equals ops dot get I, else continue. Possible ops dot get I. Okay. My bad. So if there's something to this, let's get it a spin. Did I overspin it? I think I overspin it. What the fuck is printing ln where? I hit twice to 3267. Well, that's because I don't break here. My sweet Lord and Savior. Okay, so part of me was, it is like I overcomplicated stuff quite a while, because I did. The other part of me is also like, well, I did learn something, so at least I didn't waste my day. Cat bad soul, right? So is it different? More importantly, is it dude? Can you please? Right, so this looks way lower. Like way the fuck lower. So the most is 12. Which means my padding is not enough. I can even go for like 13. No, just to be safe. What? What? slow. But just visibly this is not enough. Why is my padding not enough? Yeah, this would work. Wait, is my sum... Oh, it's a U sides. Do I have somewhere a not U sides? Is that what's happening here? No. No. Yeah, this is very low. So I'm not hitting anything. I'm misunderstanding something about the problems because I should be hitting every possible sequence, no? So I don't jump any. It's interesting. And by interesting, I mean this is infuriating. So the sequence was 12. 12 before 94, 95. Sure. Which, by the way, would be more elegant if I don't say this. Right? Same shit, but Yeah, which sounds nice because I can say that it is like 12. Wait, Python. It sounds like enough combinations, but I'm not hitting a lot of stuff. Oh my god. This is the only U32 that I have, and I'm not even using it. The sum is a U side, so it should be able to hold. The ACK is also U sides, so it should be able to hold. Unless I want to be safe and I could just go U64. ACK should also be U64. Yeah, but U64 is U sides is fine because my system is 64. My man. Why is it less though? Yeah, man. I don't quite know where does this head. Because what I believe it should be happening is, so let's see if this is happening how I believe this is happening, is that I'm matching and let's say Right. So, oh, now wait. Should be also print a new line here. There you go. So on my sequence 180 is plus times. On my sequence 367 is... Oh. Yeah, that explains it. Okay, so my reasoning is absolutely wrong. So it should be plus times. This isn't how I pick. I shouldn't be picking it over here. I probably should pick it over here. What happens if I do that? Because I want to incrementally pick it based on the position. This also means I don't need it to be like that, but it to be here. Nope. This is definitely how it stays. Getting way absurd. Man. So in simple case, it would be plus and this, right? This should be okay. By the way, let's remove a little bit of our padding to make it more clear to myself. Be like 4. Hell, even 3 is enough in this case. Okay. So my 90 is going to get a plus and a times. This guy should be getting a plus plus, and we're seeing it, a plus times, and there should be a times somewhere. Oh yeah, this doesn't work as well. But I should be being in a least significant, right? Yeah, sorry about that. So this one as well doesn't work. Fucking hell, man. What's the problem now? So 0, 1, then 0. Wait. Why does this doesn't change? That's why my stuff over here is changing. Yeah, see? The fuck is this shit? P plus times, plus times, plus times, yeah. 1, 2, 3, 4 possible occasions, and 1, 2, 3, 4, 5, 6, 7, 8. Am I not getting every possible one? I am. So that means I'm using it bad. God damn it, man. Okay, now it's problem that I'm not really getting the correct possible calculations. I should try every iteration up until length. That's the problem, right? But I ain't doing it over here. Oh my god. All right, well, let's say, what? All right, because I have to break here. I have to break it here. I'm trying every permutation, right? Let's say this one. With 6 permutation, I get only 4. Why I get only 4? Which length am I using? Inclusive? Okay, this looks better. It's still short. Like, this isn't it. All right, padding, padding, padding. Get the padding back to 14. Or fuck it, 20, I don't know. Dude, still doesn't work. I wanna cry. Yeah, see, this isn't a hit. This sequence is about 8. So there should be 7 Python how to make what's this called? Bang math operator. Not negation. Oh my god, what the fuck is that even called? Well, I can do n times, so it's going to be 7 times 7 minus 1. Can do that. I don't 3. 7 times 7 minus 1. It should be 24 possible iterations, but I don't hit and I do only this many. Yeah, because I'm not doing how many lengths there are. I'm doing how many possible operation there can be. There should be let pos op possibilities equals dot sequence dot len, and this is going to be t times t minus 1 halved. So we go up to possibilities. Still low. Better. Definitely better. Still low. Yeah, because this is short, right? Yeah. Now I'm getting lost. But this looks like 24 operation this time. Doesn't it? 24 up, 24 up. More than 24. Well, doing more is not going to hurt me. Well, in this case, it will be plus times. Plus times times times. Plus plus. Plus time plus. Time plus. Plus times times and times times times. Wait, no, this is 3 numbers, so I should be removing my 20 padding here and putting 3. So I can take a look at what's happening here. So it's going to be plus plus, plus times, plus times times, times times plus, plus plus times, plus, yeah, we have every possible number over here. So at the very least, in this case, I should be doing better, right? What if I up my permutations? Since I have 2 possible operators. Yeah, it takes a year. I mean, I'm delusional, but sure, why not? Too low. Yeah. Alright. I'm upset now because I feel like this should work, right? Give me 1, 2, 3, 4, 5, 6, 7, 8. Wait, 1, 2, 3, 4, 5, 6, 7, 8. There's only 6 here. There's only 5 here. But we should get things better. Shouldn't it be like a bank operator? Bank math operator. Well, this is not long enough, which is good. At least I know what to do. So we should go higher than this. And take a long ass time to compute, won't it? Six. This is new. Still not enough. Yeah, so 1, 2, 3, 4, 5, 6, 7. It's even more. Oh, bitch. Even higher? Wait, it wasn't Gauss, it wasn't 1, it was 2? This looks like a big number, but still not big enough. Yeah, not big enough. But we're getting places. Still not a hit, but I'll leave it at that. There's still more. Wait. Son of a bitch. This is a big number. Wait, no, it isn't. What if I always do the same? It's probably gonna take a bit of time, but now this feels like a big boy. Okay, this is the biggest boy yet. Oh my god. Oh my god. Okay. I over the topped it, but that's okay. But the fact is that I don't understand how many are the possibilities. How many are the correct possibilities? Like how much? This is still kind of long. Now the subreddit actually spoiled me. The J seems concerned the total calibration nowhere close to being written with safety tolerance, then you add your mistake. Some well-hidden elephant are holding a third type operator. The concatenation operator combines the two digits from its left and right input into a single number. For example, would become this. Operators are still valid left to right. Now, apart from the three equations, how could you make true only using addition or multiplication? The above example has three equations can be insert operator. Adding up 6x value using pi produce the new total calibration of 1, 1, 2, 3. What's your new knowledge? I'm gonna say that since I'm doing this insanity and relying on this stuff, I'm gonna say that I can just add another layer here, you know? And just add the iteration. That's gonna be stupid. So, concat. Be like a pipe. Yeah. My bad. Concat. And I'm simply will add here the concat, which will be like doing that insanity from, so I should convert them both to strings, stick them up, convert them back. So step 1 is, I don't remember how to do Rust from num to string. Okay, so that would be let tmp, let concat equal act to string plus at deref l to string motherfucker. Okay, So this should be my string, right? Right. By the way, it's not a mod, it's a concat. Right, right. Okay, so this is my string. Now I got it back to a number. And I make that arc is equal to there. So arc, okay. Let sum, I can unwrap here. So arc is equal concat, motherfucker. Concat parse u64, something like this. There was a part somewhere. I remember it. It's parse. No. Well, from string to num rust. It would be like parse. And unwrap, motherfucker. Unwrap. Okay. Let's take an example ride. That's not that different. But because my example input should be changing, right? Wait, there's no example? Hello? Gaussian operator combines the digits from its left and right inputs into a singular. For example, that would become this. All operators are still valid left to right. Now, apart from the 3 multiplication that could be made through using only addition and multiplication, there's 3 more equations that can be made through. So 15 can be made through a single concatenation. Oh yeah, because I need to up the possibilities. So should, yeah, I'm changing everything. Because I should be putting the concat in. Which is a big bad deal. Well, Rust from int to ternary. Means I have to implement this from my own. Okay, this won't change anything. But I can put it with a sum. Like my vec can be 13 long. So that's the padding. And my padding is going to be whatever. And then I do the ternary operation. And then stuff works. Okay, let's try. Wait. Always greet the girlfriend. Actually, I have something to do. Be right back. Okay, so back in business. We were talking about the concat. Now, the holiday of concat. Okay, the holiday of concat. Like I need to simulate this idea, which would mean that I can do like an empty vec, or rather I can put a default vec, say sum. It doesn't really matter. So make a full vec fast. If there's a way that I can just push up a lot of values, not like this, this one. Okay. I guess I don't even need to. Very well. In this case, it would be like our padding is 13. Rather, our operation, let's say that it's sum, and should be 13, which would be the padding, right? So this is what happens. It's a padding of pluses. Now, rather than pushing it every time something new, we're gonna do the division, gonna emulate, we're gonna transform it in base 3, and by base 3 we're gonna exchange the first one and keep it going. And that would happen up until the number is real. So let's say, by the way, okay, so this is good. Let's say now that let mute count, actually it's going to be index equals 0. Now we have our number, which is good. So we're gonna loop ad infinitum. We're gonna take let it's reminder in English, I think. Reminder math. Yeah, the rest reminder. Okay, so let reminder would be num mod 3. Num equals num times 3. But we can copy it, honestly. Let mute num equals num. And num is going to be num times 3. Okay. Reminder, no reminder. And now we're going to check on our reminder. Gonna fucking match, please. I'm gonna let the compiler work. Son of a bitch. Can't match your sites. Okay. Fine. So if it's Sue, we're gonna put in the index on my op dot index equals operation molt. Paste this a couple of times. So one as before, well, it doesn't really matter. We're going to be concat sum and mod. Doesn't really matter at all. Okay. If num equals 0, I guess, break. So when we get down, we should break. Let's move the print in part 1 and let's see what's going on over here. Doesn't look good. No, it does not. Alright, this should be 3 times as big. So rather than 13, it should be like, well, our case should be like 12, so this should work. But doesn't look that way. Oh my god, the index. Index plus plus. If you're not breaking, we should be, well, index plus 1, sure. Sorry, for a second. Okay, very well. Then our index wasn't getting up, so that looks fine. Plus times pi, plus times this looks maybe good. I don't quite know. Let's get 0, so probably isn't doing every possible iteration. It should be high, right? Well, right, because the 2 right now I'm using as power of 2, but this should be like a power of 3. Be way more possibilities. Yes. And my example this time should look like 11,000. Okay, so this looks better. So I never hit. That didn't look good. Yes, because it's going to be, we can make it shorter for this time for presentation purposes. Let's say 5. Okay, so that's been times plus times. The implementation part is here, so I wouldn't be too worried about that. What I want to be worried about is what happens when we're here. Like, what is going on over the operations? So we will always... so I want to print out what's going on and see and debug the same way before. Wait, it's not being reversed. That's not good. Alright, I don't need to reverse anymore. 11. Well. Can't wait to show this to my friends. They're gonna be thinking I'm crazy. No, don't print shit. Don't care about printing shit. Go. It's gonna take a little bit of a time. Wonder if my CPU gets fucked up. The fuck is this? A hit? Like, what am I type printing? But actually, let's print the hits only to be able to debug how long it's taking. 11 225. Okay, so 13 lines was basically instant. So I can wait that long. I'm gonna say out of all brute forces, this is stupid because I'm checking way too much and I should be able to say the precise amount of checkings. But this is being fun, so why not? Because the precise amount of iterations would it be 3 times len? Rather 3 times mod. I don't need to check every possible. Five of 4. So we're at half. I can wait. Because I'm pretty sure this would work. Yeah, I read about this idea from a subreddit. So I think it's a cool idea. I think there's better ways to do it. Possibly the best way to do it is with the trees. I tried that approach on Saturday, but it didn't work out nicely for me. Therefore, I just said, whatever, let's get this done. I mean, in any way that I get it done with my reasoning and my Rust, it's a win because I get to learn how to do it. It's not really that important that I don't think that it's necessarily important that it's going to be the most optimized or the most smart position. At the end of the day, Like Prime described it as a, okay, this is a big number. Prime described it as this is a lead code, and as for now, I never had to do lead code, so I don't think. First try. Okay. Honestly, it makes me super happy. I can always get back if I'm ever feel like life is getting too easy. Alright, so we are just a little bit behind. And I say this is not as behind. Again, first off, it's a win because I'm already at day 8 and I never got so far. There's a map. Okay. In 40 minutes, I guess I could set this up. I can set it up and see what's going on. Then we'll take a look. Okay, you find yourself on the roof of the top secret Easter Bunny installation. While the historians do their thing, you take a look at the familiar huge antenna. Much to... oh, well. Let's edit this. Day 8. Good. Much... the fuck is going on? Here, we can remove this from my face. We can copy the template, recursively copy the template to day 8. And then we can go to day 8. Don't know why it will. Oh yeah, part 1. And there you go, son. Alright, find yourself on the roof of the top secret Easter Bunny installation. While the historians do their thing, you take a look at the familiar huge antenna. Much to your surprise, it seems to have been reconfigured to emit a signal that makes people 0.1% more likely to buy Easter Bunny brand. Imitation mediocre chocolate, Christmas gift, unthinkable. Damn, this looks so weird, this word. Scanning across the city, you find that there are actually many such antennas. Each antenna is tuned to a specific frequency indicated by a single lowercase letter, uppercase letter, or digit. You create a map, your input, of the antennas. For example, this is a map search, so 000AAA. The signal only applies its nefarious effect on specific antinodes. Antinodes? How would you pronounce this? Pronunciation. I would pronounce antinodes.
Antinodes.
Antinodes, nice. Based on the resonant frequencies of the antenna, in particular, an antinode occurs at any point that is perfectly in line with two antennas of the same frequency, but only when one of the antennas is twice as far as the other. That means that for any pair of antennas with the same frequency, there are two antinodes on each side of them. So, for these two antennas with frequency A, they create the two antinodes marked as hash. Adding a third antenna with the same frequency creates more antinodes. It will be ideally add 4 antinodes, but 2 are off the right side of the map. So instead, that's only 2. Antennas with different frequencies don't create antinodes. A and A count as different frequencies. However, antinodes can occur at a location that contains antennas. In this diagram, the lone antenna with frequency capital A creates no antinodes but has a lowercase a frequency antinode at this location. Oh my god. I didn't get any of this. Okay. So you can see each antenna is tuned to a specific frequency indicated by a single lowercase letter, uppercase letter, or digit. You create a map of these antennas. Okay, so it can be 0A or capital A. It refers a specific antinodes based on the resonance frequency of the antennas. In particular, an antinode occurs at any point that is perfectly in line with two antennas of the same frequency. But only when the two antenna is twice as far as the other. This means that for any pair of antennas with the same frequency, there are two antinodes, one on each side. So for these two antenna frequency A, they create two antinodes marked as hash. Kind of confused about this idea. Not gonna lie. Like, what is going on here? So this is position 4-5. This is 2-4. Doesn't look to me like this is position 6-6. 8-7. By the way, they don't feel. This is 4-5. This is 6-6. Doesn't feel like on the same alignment. Okay. We're saying, I don't understand this. It says that based on the respondent frequency, in particular, an antenna occurs at any point that's perfectly in line with two antennas. A point that is in line with two antennas. Like, what do you mean by in line? This is not in line. I don't understand this. I literally can't. Like, my dude's actually done. My dude's actually got this so fast. I don't even understand the text. I don't understand what do you mean that there's. In particular, an antenna occurs at any point that is perfectly in line with two antennas the same frequency, but only when two antennas is twice as far as the other. Like, it would be like a square, because I see the square idea here, right? And then there's a square here, then there's a square here. So it would be like corners of a square. That's the idea. Let's try to see here. Adding a third antenna of the same frequency creates several more antennas. It will be ideally 4 antennas, but they are off limit side of the map. So instead there are only 2. So let's say that this is a square, right? So this is a square. So this is the same square. I think it's like if you trace a line passing to the 2A, the 2B are on top of that line. Yeah, that looks like that. So it should be like the corners of a square. But that's not quite a relationship because this is 3-1. This is 4-2. So that would mean that the difference between this and that would be like 1-3. Yeah. So here we added 1 and subtracted 3. Yeah, makes sense. So you'd want to move in a diagonal, and it would be the math reasoning based on. Okay, there was a formula for this. It was like the distance of the point. Okay, I'm starting to understand. Antenna of different frequencies don't create. Anyway, hello, I'm Betab. Nice having you here. How is your advent of code going? Antenna of different frequency don't create antinodes. A and A count as different frequency. However, antennas can occur at a location that contains antennas. In this diagram, this lone antenna with frequency capital A creates no antenna, has a lowercase a frequency and at its location. Okay, so I ignore whatever it is here. Not doing it. Well, you're saving yourself from therapy. The first example has antenna of two different frequencies, so the antenna they create looks like this, plus an antenna overlapping on the frequency of A. Okay, so these are the guys, and they would create, right, so basically I have to get the difference between the nodes. This will give me the pattern to which I do antennas. I have to check the patterns to see. Yeah, because this is 4 and this is 4 up, this is -4 down. Which means there has to be like a node on a opposite, it should be 4 down. Yeah, there's a lot of math here. Should be that hard, but there's a lot of math. Because the most top A frequent antenna overlaps with a 0 frequency antenna, there are 14 total unique locations that contains an antenna within the bonus map. Calculate the impact of the signal, how many unique locations in the bound contain the node. Okay, let's remove this. Nice guy. Okay, don't know why it took so long. And let's think about it for a second. If I say have my 0 antenna here and 0 antenna here, this is 1, this is 2, this is 3, and this would go down 1. There should be a point and down. Okay, and same way here. So this antenna goes to -3 respective to this position and +1. And this antenna is +3 -1. Now this should be the corner for my, this should be the corner from my antinode, and somewhere here should be the corner of my antinode, right? And I don't care in any possible way what here is. Well, now this antinode would be, should give them some position so I can understand what the fuck is going on. Like, let's say this is, I'm getting it way too big to get positions. So again, I'm subtracting from the node -1, but it would be, I'm mapping Batsu in this case, because I go again 3 to the right, so it's a +3, right? And here is a 1, so +2. Oh wait, draw it in the incorrect way. It's an incorrect manner. Should give them positions and make the square smaller so I can understand, so I can easily recreate every possible equation. All right, so 0. There's a node here, there's a node here. Let's do 3. And 0. Is this a square? No, it is not. So yeah, 1, 2 up, 1, 2 up. So 1, 2 up, 1, 2 up. This should be my matrix. Let's put the squares here. Then it will be 1, 2 hash and 1, 2 hash. And now we can put a 0, 0, not zeros, but we will dot it out. All right, so starting point 0, 0. Actually, there's one more line. There we go. Okay then. Here's my 0, 0. My point over here is a good old, so 1, 2, 3, 1, 3. This one would be a 0. This one is a 0. How many are there? 5. Great. This one is a 3, 2. This one is a, actually not, the opposite. 1, 2, 3, 4. 1, 1, 2, 3, 4, 0. All right. Then, at this point, we can do the mod of this subtraction. So that will leave me to 1, 1 is their distance. Yeah, I put one anti-node in the incorrect position. Don't even need this. My anti-node should be here. This is so painful to do. Okay, so in this case, the number kinda change. This time is a 2, again 3. Yeah, still looks good. This is a 0, 1, 2, 3, 4. All right then. Now we're having this. So the modular way of subtracting, it will be 1, 1. But this isn't that helpful. Otherwise, if I subtract it as ones, this is minus 1 plus 1. So this is my mod. This is bottom one. And the top one would be minus 1 as well. You have to change chords in 2 lower points too. Oh, right. Now that's why this doesn't look good. Yeah, because I added one. Yeah, you're right. I added one row. We 1, 2, 3, 4. God damn it. 4, 2. And 5, 0. All right. So yeah, we were saying now that changes everything because my mod at this point would be 2, 1, which is better. I don't think I'm gonna need to use the mod because the mod would be 2, 1, which is good. But if I subtract the lower node with the upper node, it would be 2 minus 1, and vice versa, it would be minus 2 plus 1. Right, so this is all of my subtraction. And this falls nicely. Okay, there's a good relation here. Because let's call them A1 and A2, right? So A1 minus A2 give me plus 2 minus 1. Two, 3, 4, 5. And A2 minus A1 is minus 2 and plus 1. Well, adding this up, it gets me 04. Why doesn't this get me 50? It isn't 51, should be 50 or 60. Should be 60. 0, 1, 2, 3, 4, 5. Yeah, because it's up. Oh, yeah. I need more. This one is wrong. Son of a bitch. There you go. 1, 1. So it should be here. Should be like 1, 2 here. Okay. And then this would be 6, 1, which makes more sense. Therefore, if we want to say B1 and B1 and B2, as well, I have the instinct to press E from the drawing software, and every time I get into the corner, and it's always hilarious. Not. Well, I guess I can just pair them to the crosses and just need to understand what I need to subtract and what I need to add. But this relationship will be easy. So if I have I minus 1, this gets me down, right? So this should be used to calculate B1 by doing A1 plus my diff, right? If I sum it up with my A1 coordinates, this works out to, which are 4, 2 to 6, 1. Okay. And in the similar fashion, if I sum up with A2, this should give me B2, because A2 is 2, 3. I subtract 1, it's 0, and I add 1, it's 4. Okay. So my formula would be, yeah, this is the formula, which would mean to get the antinode on the one I'm standing, let's say I get point A, right? I need to mark a couple and then use this formula to calculate this antinode. And the antinodes should not care about what's on the top, but they should be, so I should couple everything in some way and then check their antinode. And afterwards we can work it out. So this gives me B1 and this gives me B2. Okay, this looks good. Now I know how do I get the antinode. Then I can overlap, it doesn't matter. So I don't check if there's an antenna. I just check that there's something that is not a point. And then overlaps is 0 frequency antinode. There are 14 nodes in total. Okay. Then I would map every symbol that's not a hash or a plus into a matrix. Then every single symbol that should be getting me 2 nodes. So I'm gonna iterate over every single one and get the unique nodes. And then I can count the antennas. That's the plan. I don't know how much I can do today. Get away to 9, but let's at least put it down. So the first thing would be get everything that's not a number and not an antenna into a, say, actually I'm gonna use a hash for this. So hash map, let antenna equals, yeah, hash map I would say of there should be a string over here, and there should be a, well, even a char, honestly. Should be a char on the left and a vec of tuples over here. A vec of chars that use sides, their coordinates. Okay. So a vec of coordinates, these coordinates would be every single antenna. Antennas, perhaps. Okay. I'm getting every single line. We say if line. Can I just match it? No, I need the lines. So for C in line dot char, we can enumerate this guy. But Imbe, I suppose you are a Rust dev. You're here. Got some other people going up and out, but mostly Rust guys. Which is great because Rust people are really cool. In the way that they are very knowledgeable. So you get a lot of good knowledge. I learned a lot thanks to this. Enumerate, thank you very much. And then I'm gonna check if, well, I can also integrate the hash map, but it's not needed. It would be that good old trick of antennas that I just did it. Hash map. I never remember. Hash map Rust. There's a lot of way to manipulate. There's a lot of ways to manipulate this. Those the or insert. So it's entry. Always this entry and modify or insert. This is the guy. Okay. So get the entry of C, which is my char. Or and modify, which would be chord. Rather than chord, this is a back. So chords and chords dot push my EJ or insert my EJ. Actually, a vec of EJ. This is unmutable. My bad. Always forget. Used binding antennas. Let's use it inside. Say less. Okay, this is a good start. Should probably print. I don't think I can print this out. I can already give me a pretty print. Always a good function. Pretty print antenna. We don't return shit. For L in hash. For L in antenna. Print L dot cha L dot char L.0, and we're going to say every single antenna over here. For L in L dot, for pause in L.1, which should be our usides, print pause at 0, pause at 1. And then we can pretty print it. Pretty print my antenna. Well, disappointing. It's because I didn't write this. Yep. Okay, we can print this. Also, we could write with if C is different than dot, or C different than star. I mean, I could collect also the antinodes. That could perhaps be a smart idea. The collecting point. Why? Brother, why am I collecting points? I should not be collecting points. I am collecting hashes. Sure. Points? Come on. Why? I didn't change anything. Why? Oh well, anyway, I have the antennas and the anti-antennas. Which would then I would iterate over every single antenna and check the anti-antennas with the formula I said before. So for every antenna, check every other antenna, except itself, obviously. And we can then try. I can just pop the antenna and see over everything else. Okay, so I'm gonna iterate over A, pop it up the value, check the anti-antennas. Because A is gonna have a relationship with any of them. With the formula I described before. So first would be, can I pop, if I say for antenna in antennas, this will give me, it's also already unzip it. It will be type and pause. Can't unzip it. Fine. All right. And I can iterate over the chars. Yeah, I want to pop it out like for wait, this is not what I want to do. I want to get out the antennas and then iterate over the antennas. I see this problem would be quite easy, just that I'm not thinking it through. Okay, iterate over every antenna and get the difference between them. See if I can pop it up. It will be different kind of types. Oh, that's why I was iterating, because it's a general idea. Okay, so for every char, I need the hash, so it will be anti-antenna equals antennas dot get the symbol hash. Okay, so there's every single position here. Sure, you borrow it. You do you, chief. Okay, but get won't remove it, right? I can remove it. Remove val from hash. Pop. Hash map rust. I have here remove. Has to be something like that. Remove. Yeah. I could already save it in another hash, can't I? Because I don't need it to be in the same hash. I can just say if it's a numeric or if it's anything than both, and if it's a numeric, just put it inside an array. Because at the end of the day, I'm still ending up with an array, which is an option, by the way. God damn it. Okay. Yeah, this just makes it harder. Let's say if C, okay, C is different than a hash, and if C is equal to hash, then we can just put it in anti-antenna. Use an and, not an or. Fair. Let mute anti-antennas. Go to vec of whatever. I know it will already complain because it's a pitch. Yes, it will complain. This will be a vec of use sides and use sides. There you go. So if C is my hash, then we can just pop it in here. Anti-antennas, but push IJ. Yeah, makes more sense. Okay. So now that we have this in mind, let's iterate over our types for A in antenna, for A in antenna 1, and this gives me my usage sides. I would want to iterate twice on this. Actually, no, I wanted to pop it up. Because I can get the iter. Here I can get the iter mutable. And can I say antenna.pop? Can't. Is that mutable? Looks like I can't pop it up. Guess if I copy it, I can then pop. Just out of curiosity. Oh, because I didn't deref it. No, it's not the problem. Wait a second, I'm stupid. Antenna.1.pop. Deref pop. Cannot be referenced. Here. Can't borrow antenna as mutable because also board as immutable occurs here. Well, if I borrow it as mutable again. Yeah, I figured this would happen. Okay, time is up. Next day, I think I'm overthinking it. Because before going up, can't I just iterate twice over it? And I didn't want the duplicates. That's why I wanted to pop every time. More than once. So I would want to copy it to be able to pop it again for in antenna.1. Yeah, but this doesn't work how I like it to. Because I'm gonna double up every time the position. That's why I want to pop it and reduce it every time. But this is the one they care about it being. I can just iterate this. So it doesn't bother me for it to be. The one that should be mutable is this guy. But if I say antenna.1.pop, cannot borrow antenna as mutable because it's also borrowed as immutable, borrow occurs here. Wait, I should iterate over the copy that I'm popping. I should iterate over the copy. I should copy, pop, and then iterate. Let tmp equals antenna.1, by the way. Simply copy this out. tmp.pop. Does pop return me? Okay. Dot unwrap for now. So let L for A in antenna.1. Actually for A in tmp. Print A, which is a vector. Of course you can't. 8.1, 8.0, 8.1. Actually, now that I think about it, I'd rather put the L over here, but it's okay. Don't care for now. Can I go around 3, 4, 4, 8, and my pretty print tells me that my antenna has yeah, some emergencies. Sure, clone it up. No big deal. Still in the testing phase. Right, so my A is 344854. I print it out. Yes, I have the pop here. I guess if I print rather than this, but the guy, I should have every single element, which it's a good setup for tomorrow to keep up. Or for tonight, I don't know what I'm gonna do tonight. Yeah. 5, 5. Oh yeah, I pop it once. This isn't... Okay, there you go. So 344855, and every time if I pretty print it, yeah, every time it gets reduced, it isn't though getting reduced, because it should print every element and then going down. Three, four, four, eight. Well, can't go more. Let's see how many are over here. 3 persons. Thank you guys for watching up. I'm gonna leave. Hopefully we find someone who does the advent for today. Yeah, because I have some problems. I'm gonna have to go to work now. Oh my god, please don't put... Okay, so this is... I know this dude, but I want him... But he's not doing the advent, so I'm not raiding anyone who's not doing the advent these days. Let's see some nice guy that's doing some advent. Odin? Sure. Wizard with a cat. Good day. Good day to you too, sir. Thank you for keeping me company. What's his name? Wizard with cat. Wizard with cat. And I would see you tomorrow. I don't know if I get anything done from up until tomorrow, because I do a little bit of sim, but we'll see. And right. See ya. Well, that's embarrassing.